In the vast architecture of the cosmos, darkness is not empty. The breeze, just to watch. Between galaxies lies a deep and ancient quiet, a silence older than stars, colder than the first moments after the Big Bang. It is a region where matter thins into a pale mist and even gravity loses its voice. Nothing is expected to move there. Nothing is expected to speak. Yet from this barren expanse, a single thread of rhythm has begun to rise, faint, deliberate, and impossibly persistent. It arrives as a pulse carved into the static of space, a whisper etched into radiation that has traveled for millions of years. Too regular for cosmic noise, too patient for the wild frenzy of a dying star. It echoes with the unsettling precision of something that knows it is being heard. Across Earth, instruments built to study the universe, vast radio dishes turning like slow machinery, spacecraft drifting on their long spirals through the solar wind, detectors anchored in frozen deserts, continue their endless watch. For decades they have waited like stone sentinels, listening to the quiet structure of spacetime. And tonight, they detect something that does not belong to nature's usual patterns. The signal repeats. It stabilizes. Then over hours, it changes. Its rhythm tightens as though leaning toward coherence, as though adjusting to an unseen listener across the dark gulf of intergalactic space. The cosmos has spoken before, through supernovae, gamma bursts, and the faint afterglow of creation, but never like this. A question forms at the edge of scientific understanding, heavy, cold, and ancient. What is reaching across the dark? And why not? After all this time? The first trace of the anomaly emerged on a night that should have passed into memory without notice. Above the high desert plateau, where sharp winds comb through long corridors of dust, a radio observatory faced the sky with the patience of ancient stone. Its dishes, immense, white, and cold, were arranged like a frozen chorus listening to the distant architecture of the universe. For years they had mapped the faint structure of the cosmic web, tracing the invisible filaments of dark matter that thread galaxies together across unimaginable distances. On this night, one of the arrays was surveying a region no one expected to give anything back, a barren stretch near a galactic filament more than 1 billion light-years away. Astronomers selected it not because they hoped to find something extraordinary, but because empty spaces in the universe often reveal the subtleties of its underlying physics. By measuring the quiet, they hoped to understand how the cosmos holds itself together. The team working the observatory followed a rhythm as mechanical and familiar as the instruments they guided. Their monitors filled with the usual static and scatter, a background hum that defines the modern language of astronomy. Much of the noise was sifted automatically by software, but a portion always required the careful attention of human eyes. Across these screens, faint signals flickered, most of them from known sources: distant pulsars, the steady roar of quasars, or the erratic flashes of fast radio bursts catalogued in recent years. This night should have been no different. Yet among the routine scatter of numbers, a single narrow pulse appeared, brief, soft, almost apologetic in its arrival. It aligned perfectly with no known celestial source. At first, the observing astronomer regarded it with the kind of quiet curiosity that comes from experience. Strange pulses sometimes slipped through the filtering system, reflections from satellites, atmospheric interference, temperature fluctuations in the receivers. There were many explanations, all ordinary. Protocol demanded verification, so the signal was isolated and marked. Minutes passed. As the telescope continued sweeping the target region, the pulse returned. Then it returned again. It arrived with a regularity that unsettled the silence in the control room. Faint, measured, and spaced with a precision that suggested something more than cosmic coincidence. The astronomer leaned forward, narrowing their attention. Their fingers traced across the keyboard, pulling up background databases and spectral references. The pulse did not match the characteristic patterns of pulsars, whose rotation produces sharp, rhythmic bursts of radio light. It lacked the violence of fast radio bursts, those unpredictable eruptions whose origins remain one of astrophysics' most unsettled debates. It carried none of the broad, distant signatures of quasars, whose supermassive black holes drown entire regions in electromagnetic fire. This was different. Too narrow for a natural stellar engine, too stable for atmospheric noise, and too quiet for any known artifact of human technology. Still, science favors caution long before wonder. The astronomer flagged the anomaly and called for a second round of calibration. Over the next hour, the team tested the receivers, checked the temperature logs, adjusted for humidity, examined the telescope's orientation, and compared the readings against nearby instrumentation. Nothing was out of place. Everything should have been ordinary. Yet the signal persisted. It was only after the fourth recurrence that the team began contacting colleagues across the facility. One by one, they approached the console, each bringing the calm skepticism of those trained to question extraordinary findings. They repeated the checks. They recalculated. They rotated the dish slightly to rule out any local interference. The pulse remained, faint but deliberate, returning with the poise of something that had always been there, unnoticed. Over the next hour, the team compared the data to the archival logs of the observatory. If the anomaly had been present in earlier observations, it might have been a technical artifact, something familiar, long buried in the system. But nothing in the database resembled what they now saw on screen. No previous run, no earlier campaign, no survey of that region revealed anything similar. Still unwilling to rely solely on a single observatory, the team sent a request for verification to 2 additional facilities on the other side of the planet. One, a mid-latitude array known for wideband sensitivity, adjusted its antennas toward the coordinates. The other, situated in a remote mountainous region, aligned its instruments with the same patch of sky. Hours stretched into the slow procession of night. The Earth rotated gently beneath them. And then, quietly, the confirmations began to arrive. Both remote observatories detected the same pulse, faint, consistent, emerging from the exact coordinates of the original finding. 3 independent systems, hundreds of kilometers apart, had now captured the signal. The probability of a shared instrumental glitch dropped to almost nothing. For the first time, the control room grew still. No one spoke. The pulse had now repeated more than a dozen times. It varied slightly as though shaped by some distant turbulence, but its core rhythm, that strange, patient heartbeat, never drifted. They mapped the signal's frequency profile. Its shape defied the broad, smoothed curve characteristic of natural astrophysical sources. Instead, it showed a narrow peak, unusual but not impossible, followed by a curious secondary structure, a faint harmonic buried at the threshold of detection. Harmonics are common in engineered signals, rare in natural ones. Yet the team refused the lure of premature interpretation. They combed through scientific catalogs, comparing the pulse to anomalous sources across decades of research. They reviewed the signatures of magnetars, the powerful magnetic stars known to produce bizarre radio emissions. The match was imperfect. They considered rotating neutron stars shedding energy through beams of radiation. Too irregular. They consulted papers on exotic theoretical objects, quark stars, the hypothetical remnants of matter compressed beyond the neutron state. Still no clear match. What they faced was not impossible. It was simply unclassifiable. By dawn, a timeline had begun to take shape. The signal was first recorded at 2:17 local time. It repeated at intervals that became more precise with each detection. The calibrations from all observatories involved remained stable. By 6:40, the team had collected enough data to rule out interference from Earth-orbiting satellites. By 7:15, even the most skeptical among them accepted that the signal originated from deep space, far beyond the influence of the solar system. The final confirmation came when the observatory compared its data with a low-orbit science satellite equipped with a small but sensitive radio detector. Hours earlier, while drifting silently above the night side of Earth, the satellite had captured the same pulse, distorted by its motion through Earth's magnetic field, but undeniably the same. At this moment, something shifted in the atmosphere of the control room. No longer were they dealing with a fleeting anomaly easily explained by mundane physics. They stood instead before a phenomenon emerging from the dark architecture of the cosmic web, a whisper rising from the cold void between galaxies, persistent enough to be noticed, structured enough to demand attention. Reports were drafted. Data was secured. Calls were made to research institutions across continents. By the time the sun fully crested the horizon, a coordinated scientific alert had been issued. A signal, faint, deliberate, and unlike any known astrophysical source, had been detected coming from one of the quietest places in the universe. And what unsettled the researchers even more was the realization that it had been there all along, waiting for someone, somewhere, to finally turn their instrument toward the right stretch of sky. The signal had been confirmed. 3 observatories, spanning continents and orbital altitudes, had registered the same pulse, faint yet unmistakably precise. Yet confirmation brought no comfort. Instead, it revealed an unsettling paradox. A signal so persistent, so orderly, that the universe itself seemed to bend to its rhythm, a rhythm that defied every expectation grounded in decades of astrophysical study. Natural cosmic phenomena have signatures, patterns encoded in the physics of mass, energy, and motion. Pulsars, those spinning remnants of massive stars, emit beams of radiation with the mechanical precision of a celestial lighthouse, yet even they wobble, decay, and drift in ways that betray their violent birth. Fast radio bursts flash unpredictably, chaotic eruptions of energy whose origins remain partially obscured, leaving astronomers straining to find order in apparent randomness. Quasars, powered by the maelstroms surrounding supermassive black holes, generate radiation across the spectrum, but their emissions are broad, noisy, a storm of light stretched over vast wavelengths. The new signal matched none of these profiles. It arrived as a slender pulse, narrow and deliberate, persistent across time and space. Its stability was extraordinary, almost unnatural, as if the source had been designed to maintain perfect rhythm for eons. It pulsed in a frequency range that existed between those typically produced by known cosmic engines, sitting where no natural source should exist, occupying a spectral niche that astronomy had long considered silent. Its regularity alone suggested a power source far beyond conventional astrophysics. To produce such precision at such a distance would require energies and mechanisms that had no known analog. Even more disquieting was the subtle modulation embedded within the signal. It was not constant. Minute variations, almost imperceptible at first, hinted at a structure that might carry information. Pauses that aligned with intervals, peaks that suggested a pattern, sequences that repeated yet evolved. Nature is rarely so disciplined. Radio emissions from stars, magnetars, or supernova remnants are driven by turbulent forces, stochastic processes that produce chaos, not careful repetition. And yet this pulse behaved differently. Its modulation implied some form of coherence, an intelligence of pattern if not of thought, a resonance that seemed to negotiate its own evolution across cosmic time. Archival investigations deepened the mystery. When astronomers delved into decades of stored data from previous surveys, faint traces of the same signal emerged. Tiny hints had been buried in earlier noise, overlooked as statistical anomalies or instrumental artifacts. The pulse had been calling for years, possibly decades, yet its subtlety had allowed it to remain hidden until the right instruments and techniques converged. The cosmos had been whispering, patiently, waiting for someone to listen with sufficient care and precision. For the first time, the researchers confronted an uncomfortable philosophical and scientific reality. The universe might be speaking a language humanity had never learned to hear. This was no ordinary astrophysical phenomenon. Its regularity, its spectral position, its faint modulation, all pointed to something beyond established physics. Producing such a signal from a distance of billions of light-years implies either an enormous energy source or a mechanism fundamentally unknown to modern science. Even hypothetical constructs such as rotating black hole jets or exotic neutron stars struggle to account for the combination of stability and subtle variation observed. The implications unsettled the teams profoundly. If a natural explanation could not be found, then one must entertain the possibility of something entirely different, an artifact of physics as yet unobserved, or perhaps a deliberate structure, an imprint of order in a universe often defined by chaos. In the quiet observatory rooms, the usual rhythm of calculation and calibration was replaced by reflection. The implications unsettled the teams profoundly. If a natural explanation could not be found, then one must entertain the possibility of something entirely different, an artifact of physics as yet unobserved, or perhaps a deliberate structure, an imprint of order in a universe often defined by chaos. In the quiet observatory rooms, the usual rhythm of calculation and calibration was replaced by reflection. Scientists, trained to separate emotion from data, now sat in contemplative silence, aware that their instruments had caught a pattern that seemed almost impossibly coherent, a pulse that suggested forethought rather than accident. Speculative models began to circulate. Could this be the emission from a previously unknown class of compact objects, whose internal physics operates on principles not yet theorized? Could it represent an interaction with a form of matter invisible to conventional detection, dark matter oscillations producing regular electromagnetic echoes? Or might it be something more radical, the faint signature of an intelligence operating on cosmic scales, a civilization or process able to modulate energy across vast distances with purpose and discipline beyond human comprehension? Despite the allure of speculation, the observational evidence remains stubbornly grounded in empirical reality. Every hypothesis would need to satisfy an unforgiving set of constraints: distance, stability, modulation, and energy output. The pulse's precise location in the sky, its repeated appearance, and its archival persistence demanded a source that was not only consistent but persistent over time, far exceeding the lifespans of known astrophysical engines. Its very existence posed questions about the limits of what is physically possible in the universe. The shock rippled beyond the initial discovery team. Within weeks, specialized groups in astrophysics, cosmology, and radio astronomy convened to examine the data. The signal became a focal point for interdisciplinary collaboration, drawing theorists who explored exotic physics, engineers who refined detection methods, and mathematicians who analyzed the patterns embedded in the pulse. Attempts to reconcile the signal with established phenomena often produced contradictions. The precise repetition implied a level of control inconsistent with chaotic astrophysical processes, while its faint strength suggested a source not readily explained by known energy scales. As the narrative of discovery spread, philosophical reflection deepened. Humanity had long considered the cosmos as a backdrop for observation, a canvas upon which the dramas of stars and galaxies played out. Suddenly, there was the possibility that the universe itself was not silent, that somewhere in the vast intergalactic void, an ordered message had been traveling for eons, waiting for instruments precise enough to capture it. The signal became more than a scientific puzzle. It became a mirror of human curiosity, a reflection of the desire to find order amid chaos, to encounter meaning in the immense and often indifferent cosmos. And so, the scientific shock persisted not merely because the signal defied known astrophysics, but because it forced a confrontation with uncertainty on a scale few had imagined. It demanded a reckoning with the limits of knowledge, a meditation on the possible presence of forces or structures beyond comprehension, and a recognition that even the most methodical observation can reveal phenomena that challenge the very foundation of understanding. The faint pulse, small and imperceptible against the infinite background, carried within it a challenge, a call to rethink what is possible in the universe, and to acknowledge that some mysteries may be older, deeper, and stranger than any mind could predict. Decades from now, the archival echoes of this signal may still be scrutinized, but in this moment, the world of science stood at a threshold. The familiar laws of astrophysics offered no ready answers. The signal's stability, its rhythm, its spectral anomaly, and its archival persistence combined to form a puzzle that resisted explanation, leaving behind a profound tension between wonder and incredulity. The universe, it seemed, had revealed a thread of order from its immeasurable darkness, a thread that might unravel fundamental assumptions about energy, matter, and intelligence in ways still unimaginable. And in this tension, the shock that arises when evidence refuses to fit expectation, the first true sense of awe settled over the community of observers. They had not discovered chaos, nor a mere curiosity of physics. They had discovered a voice rising from the intergalactic void, a pattern that spoke in a cadence beyond prior understanding, a signal that demanded both rigorous inquiry and quiet, philosophical reflection. In the silent observatories, under pale fluorescent lights and across cold desert air, scientists felt it. A confrontation with the unknown, the weight of possibility, and the first undeniable suggestion that the universe might be speaking in a language humanity had only begun to notice. As the days passed after the initial detection, the scientific community shifted into a new rhythm, a cadence of observation and analysis that mirrored the quiet pulse of the signal itself. The anomaly that had first emerged on a single radio array was now being scrutinized by multiple observatories around the globe, from sprawling interferometric networks that spanned continents to space-based detectors drifting above the Earth, free from atmospheric interference. Each instrument offered a different lens on the same whisper, and with each perspective, the signal's depth became more evident. Spectral analysis revealed layers within the pulse, subtle harmonics hidden beneath its primary frequency. It was as if multiple voices overlapped in a single note, each layer maintaining coherence yet interacting in patterns that suggested purpose rather than chaos. The mathematics of interference, the physics of resonance, and the known behaviors of natural celestial emitters struggled to account for such structure. Pulsars and magnetars could produce harmonics, but these were predictable and consistent with models of rotational energy and magnetic field decay. This signal, however, displayed a complexity that seemed to grow over time, revealing finer subdivisions of rhythm and amplitude across days and weeks. Mapping the origin of the pulse pushed the limits of current astrophysical techniques. Triangulating across arrays of telescopes, scientists located the source beyond the spiral arms of the Milky Way, in a vast intergalactic void where stars were sparse and matter existed in diffuse clouds almost imperceptible to observation. The signal emerged from a region of near-nothingness, an expanse so empty that conventional astrophysics would suggest little could be there to produce any emission at all. Yet from this void, a coherent rhythm pulsed across billions of light-years, traversing space with an eerie precision. Over time, subtle changes in the signal were recorded. Its pattern evolved, its structure becoming incrementally more complex, revealing layers of modulation that suggested an underlying logic. Some frequencies strengthened while others diminished, shifts occurring in sequences that hinted at mathematical consistency. Researchers noted intervals that aligned with prime number spacings, repetitions that suggested not random variation but deliberate structuring. Quantum scale regularities, oscillations potentially consistent with minute energy fluctuations at fundamental levels of matter, appeared embedded within the pattern. The signal behaved like a message unfolding gradually, its complexity increasing not randomly but according to rules that had yet to be deciphered. The implications sparked heated discussion within the astrophysical community. Some argued for extreme natural phenomena, unknown classes of compact objects, hyperenergetic plasma interactions in previously unobserved states, or gravitational lensing effects creating the illusion of structure. Others considered a more extraordinary possibility, the first evidence of intelligence operating on a scale so vast that it approached the cosmological. Could the signal represent deliberate modulation, a language encoded in frequencies spanning intergalactic space? Was the pulse a cosmic Morse code, a structure of information written into the very fabric of radiation? To probe these possibilities, scientists employed advanced computational techniques. Machine learning systems were trained to detect patterns and correlations beyond human perceptual limits, algorithms designed to differentiate signal from noise in ways classical analysis could not. These systems began to reveal hidden symmetries, internal consistencies within the pulse that suggested an intricate architecture. Recurring motifs, nested cycles, and subtle phase relationships emerged, invisible to the naked eye yet persistent across the duration of observation. Each discovery reinforced the mystery. The signal was neither fully chaotic nor fully predictable, but balanced on the threshold between natural astrophysics and something far more enigmatic. The international collaboration expanded to include mathematicians, information theorists, and quantum physicists. Their task was not merely to detect or measure the pulse but to decode its potential structure. Prime number intervals, Fourier-like harmonic series, and oscillatory patterns resembling quantum coherence all became points of intense scrutiny. Some proposed that the pulse might exploit universal constants, mathematical properties inherent in the cosmos, as a medium for communication. Others hypothesized that its gradual evolution over weeks might reflect an adaptive process, a signal learning, adjusting, or responding to the environment of space through mechanisms not yet understood. Simultaneously, the study of the source region continued in other wavelengths. X-ray and ultraviolet observations revealed only faint background radiation, nothing commensurate with the energy implied by the radio pulses. No obvious astrophysical engine, no star cluster, no accretion disk, no supernova remnant, corresponded to the signal's coordinates. Its location, suspended in a near-empty void, defied expectations. The energy required to generate a coherent pulse across billions of light-years without detectable emissions in other bands suggested either a fundamentally new physical mechanism or an as-yet unimagined engineering feat, if intelligence were involved. The deeper investigation reshaped the scientific narrative. The signal was no longer merely an anomaly. It had become a probe, a subtle test of human understanding of physics, cosmology, and the limits of observation. Each harmonic, each phase shift, each minute evolution posed new questions. How could matter and energy behave in ways that produced such stable modulation? Could the coherence persist across intergalactic space without significant dispersion? Were these patterns evidence of natural resonance or intentional design? Ethical and philosophical reflections accompanied the technical work. Observatories became spaces not just of measurement but of contemplation. The pulse demanded patience, not speed, understanding, not assumption. Scientists were forced to reconcile the certainty of empirical data with the uncertainty of interpretation. The possibility that intelligence might exist in such a remote, desolate region provoked awe and caution alike. It was not a question of immediacy. The signal was faint, slow, patient, but of scale, of perspective, of the recognition that the universe might hold entities or processes far older, far more enduring than humanity itself. As computational analysis progressed, correlations within the pulse began to hint at emergent complexity. Patterns nested within patterns, structures repeating at different scales, suggesting hierarchical organization. Some researchers speculated these could correspond to symbolic encoding, perhaps leveraging universal mathematical relationships as a medium intelligible across civilizations or epochs. Others proposed that the signal could be a natural phenomenon, the manifestation of processes operating on scales of energy, gravity, and quantum mechanics currently beyond observation. The line between natural and artificial blurred, leaving only questions that were simultaneously technical and existential. In parallel, the international teams refined observation protocols. Coordinated campaigns synchronized multiple telescopes to track the signal over extended periods, mapping phase shifts and amplitude variations with unprecedented resolution. Algorithms cross-validated datasets, compensating for terrestrial interference, solar activity, and cosmic noise. The aim was not merely to record the signal but to extract its internal logic, to discern whether its evolution followed natural laws, probabilistic processes, or deliberate structuring. Weeks into the investigation, the pulse revealed a subtle acceleration in its complexity. Not in amplitude, not in energy output, but in pattern. Each recurrence introduced nuanced variation, a refinement that suggested the signal was not static but dynamic, evolving. Some researchers proposed that this could reflect an astrophysical process adapting to environmental conditions, shifts in magnetic fields, gravitational interactions, or plasma behavior. Others considered a more radical interpretation, that the signal itself might encode an intentional progression, a learning process unfolding over time, its logic hidden beneath layers of frequency and amplitude modulation. Through it all, the signal remained profoundly elusive. It was persistent yet intangible, measurable yet incomprehensible. It challenged the limits of instrumentation, analysis, and imagination. Each new harmonic, each emerging symmetry, reinforced the duality of the mystery. The pulse was both a physical phenomenon and a philosophical enigma, a bridge between observation and wonder. Ultimately, the deeper investigation revealed not just the signal's structure, but its effect on the human mind. It reshaped expectations of what could exist in the voids of space, demanding humility before the immensity of the cosmos. It forced a reconsideration of intelligence, of physics, of the possibilities hidden in intergalactic silence. And it left a lingering question that echoed across observatory halls and quiet laboratories alike. Was this pattern the product of nature, or the first faint murmur of something deliberately reaching across the abyss, inviting understanding from a species yet to fully listen? The signal had become more than a puzzle. It had become a mirror of cosmic possibility, a meditation on coherence and chaos, on order emerging from emptiness. Each pulse, each harmonic, each subtle evolution told a story, not yet fully readable, yet undeniably profound. And as the telescopes continued their patient rotation and the machine learning algorithms probed deeper into its hidden symmetries, the universe waited, quietly, for the answer that might lie beyond the edge of human comprehension. As the observation campaigns continued, the signal began to reveal properties that unsettled even the most experienced astronomers. Its rhythm, once considered stable yet enigmatic, was now subtly shifting. Careful analysis showed that the frequency of the pulses was drifting, a gradual acceleration that could not be explained by conventional astrophysical motion or the expansion of the universe alone. It was as if the signal itself were moving or being moved through the fabric of intergalactic space, traversing distances that dwarf comprehension, and doing so with a precision and persistence that challenged every known law of physics. This drift suggested enormous underlying forces. If the source were an object emitting electromagnetic pulses, it would require energy output on scales far exceeding that of even the most powerful quasars or gamma-ray bursts. Its persistence implied a mechanism capable of sustaining such output over unimaginable distances and timescales. The astrophysical models strained under the weight of this anomaly. Rotating neutron stars, supermassive black holes, magnetars, each offered familiar templates for powerful signals, yet none could reconcile the combination of acceleration, coherence, and faint intensity observed. Further study revealed additional, more subtle anomalies. Slight gravitational distortions were detected in the vicinity of the signal's origin, shifts in space-time too minor to be associated with any visible mass, yet detectable in the careful alignment of multiple arrays. Observatories noted faint ultraviolet glimmers coinciding with the radio pulses, tiny flashes that seemed to echo the main signal but without the energy expected from known cosmic processes. Historical archives suggested that earlier, weak pulses might have occurred decades before, leaving faint traces that, when reanalyzed, aligned with the modern signal. Each new measurement layered complexity upon complexity, revealing a phenomenon more intricate than ever imagined. The contradictions multiplied. The pulse was too regular to be random, yet too complex to arise from any known natural source. Its faint intensity implied that if it were artificial, the energy required to sustain it across billions of light-years would necessitate engineering on a cosmic scale, a civilization or process operating with powers beyond any human conception. Yet attempts to reconcile it as a conventional artifact failed repeatedly. The energy, the coherence, and the location all resisted ordinary explanation. Some physicists began exploring a radically different interpretation. Perhaps the signal was not being emitted at all. Instead, it could be a reflection, a scattering of something far larger moving through space-time itself. If a massive object, an unseen remnant of cosmic structure, a clump of dark matter, or even a topological feature of space-time, passed through the intergalactic void, it might interact subtly with the cosmic microwave background or the fabric of space, producing a ghostly echo that appeared as a coherent radio pulse. In this view, the signal was less a message than a shadow, a modulation of space itself reverberating across unimaginable distances. These ideas sparked intense debate. Could such a process produce the precise mathematical regularities noted in the signal? Could it account for the evolution and apparent adaptation of the pulse over time? Or did the explanation lie elsewhere, in mechanisms still unimagined, beyond the scope of current physics? Researchers began exploring connections to exotic theories, gravitational lensing at unprecedented scales, interference patterns in the quantum vacuum, or even the effects of dark energy fluctuations. Each hypothesis remained speculative, yet all shared a single implication. The cosmos was offering evidence of processes far stranger and more powerful than previously observed. The escalation of the mystery forced scientists to reconsider their assumptions about space and energy. Observatories, once instruments of passive observation, became tools of active exploration, attempting to correlate the signal with every measurable phenomenon in its environment. Each new detection added nuance and tension. Slight modulations in amplitude hinted at interference or reflection. The frequency drift implied a velocity and mass interaction impossible under known physics. And yet the pulse remained, faint yet coherent, persistent yet evolving. With every additional observation, the human imagination stretched further. Could the acceleration signify a moving structure of immense scale, something so massive that its passage warped spacetime itself, bending light and radiation in ways that reached Earth as an echo of its motion? Could the faint ultraviolet glimmers be incidental energy leakage, a trace of the object's journey through intergalactic matter? Was the signal a cosmic experiment, a natural process operating on scales beyond comprehension, or something deliberately constructed to endure across time and space? The deeper the investigation went, the more the boundaries between physics, philosophy, and speculation blurred. Researchers were confronted with possibilities that stretched conventional understanding. A signal reflecting spacetime distortions, a pulse evolving according to hidden mathematical rules, or even the faint footprint of an intelligence capable of shaping energy across billions of light years. The signal had grown from curiosity to a profound confrontation with the unknown, a challenge to the very way humanity perceives the universe. In observatory control rooms, the atmosphere became a mixture of reverence and tension. The instruments hummed and rotated, synchronizing with a precision that echoed the signal's own pulse. Analysts plotted frequency drifts, charted harmonics, and fed data into increasingly sophisticated models. Each iteration revealed new anomalies, new symmetries, and new questions. The signal's faint acceleration was now not just an observation but a narrative thread. Something vast was in motion, something interacting with space and energy on scales beyond comprehension, and the evidence lay in the subtle, elegant drift of a pulse crossing the intergalactic void. Philosophically, the escalation forced humanity to confront the possibility of forces and processes far larger and older than civilization itself. The signal demanded patience, observation, and humility. Its subtlety was a reminder that the universe's mysteries are not always immediate or violent. Some emerge slowly, persistently, testing understanding over decades and centuries. It was a rhythm that required attentiveness, a story written across the silent canvas of space, unfolding in ways that could only be understood with careful reflection and rigorous inquiry. In the midst of this escalation, one question loomed more insistently than all others. What was moving through the void, if indeed the signal's drift represented motion rather than emission? Its velocity implied a scale of energy or mass far beyond anything observed in natural or artificial processes. And yet, whether natural, engineered, or an as yet unknown interaction of space-time itself, the pulse continued to reach Earth with an almost patient persistence, like a cosmic clock slowly ticking across the void. Each discovery, each contradiction, each subtle anomaly deepened the mystery. The signal remained at once fragile and enduring, faint and yet impossible to ignore. Its acceleration hinted at vast energies, its modulation at deliberate structure, its location at the edge of emptiness. It was no longer merely a puzzle for astrophysics. It had become a lens through which humanity glimpsed the profound strangeness of the cosmos, a reminder that the universe holds secrets that defy comprehension, and that even the faintest whisper across intergalactic space can carry profound implications. As researchers continued to monitor, model, and hypothesize, the signal pressed forward across the void, a thread of coherence in the silent expanse, defying conventional understanding, challenging assumptions, and silently asking, what is moving through the darkness, and why has it chosen this precise rhythm to make itself known? The signal had grown beyond an anomaly. It had become a mirror reflecting the limits of human understanding, a puzzle that demanded new frameworks of thought. As astronomers, physicists, and cosmologists scrutinized its structure, its drift, its harmonics, and its persistence, a landscape of speculation unfolded, theories that ranged from the extremes of known astrophysics to ideas hovering at the very edge of imagination. Each carried profound implications, threatening to rewrite the boundaries of physics, of time, of intelligence in the cosmos. One of the first hypotheses centered on exotic stars. Perhaps the pulse originated from a type of compact object yet unobserved, a magnetar or quark star behaving in ways never seen before. Magnetars are neutron stars with magnetic fields trillions of times stronger than Earth's, capable of emitting sudden bursts of radiation, yet even they have lifespans measured in thousands, not billions, of years. Quark stars, hypothetical remnants where matter exists in a free quark state, might generate unknown electromagnetic signatures. Could an object of this sort, at an extraordinary distance, produce a signal so faint yet so structured, a pulse that modulated with almost mathematical precision? While mathematically conceivable, the extreme stability and layered harmonics defied even these rare and violent stellar phenomena. Another idea looked to the edges of theoretical physics: warp-driven objects. A vessel or structure moving through space-time via an unknown propulsion method, bending the very fabric of the cosmos, could in principle leak energy in a patterned wake, producing the observed pulse. The concept drew from Einstein's equations, from the Alcubierre drive hypothesis, in which space-time itself is contracted and expanded around a craft. If such a warp were imperfect, subtle radiation might escape as a signal, faint and regular, traversing billions of light years. This theory was provocative. It implied either an intelligence capable of manipulating space-time itself, or natural processes that mimic the effects of warp-like distortions on a cosmic scale. Some speculated on cosmological engines, massive structures built to harness energy from black holes. Using mechanisms akin to the Penrose process, rotational energy from a spinning black hole could, in principle, be tapped and modulated. If an advanced civilization had constructed such a megastructure in an intergalactic void, it might produce regular electromagnetic signatures as a byproduct, faint pulses echoing across the universe. The pulse's faint intensity, combined with its coherent rhythm, suggested that if such an engine existed, it would operate far beyond anything conceivable in human engineering, requiring control of energies and structures on a scale that dwarfs entire galaxies. Other experts ventured into the most speculative realms: multiverse leakage. In some interpretations of string theory and brain cosmology, quantum tunneling between universes or higher dimensional membranes could produce measurable effects in our own spacetime. Could the signal be the faint residue of such an interaction, a pulse born not from matter or energy in the conventional sense, but from interference between realities? If so, the signal was a message of the cosmos itself, an imprint of existence beyond our familiar three-dimensional space. The very fabric of reality, in this view, might occasionally whisper, leaving traces in electromagnetic fields detectable by instruments attuned with extraordinary sensitivity. A fifth, more temporal hypothesis suggested the pulse might be a relic of pre-technological physics, a natural phenomenon from an epoch before galaxies, stars, or planets formed. The early universe, in its first million years, experienced processes largely inaccessible to direct observation today. Quantum fluctuations magnified during cosmic inflation, relic radiation patterns, and transient structures that could have imprinted signals into the fabric of spacetime. If the pulse were such a remnant, it would be a message older than anything currently visible, a fossil of a universe in its infancy, waiting to be interpreted billions of years later. Debates intensified among theorists. Could Einstein's relativity fully describe the propagation of such a signal? Were gravitational distortions hinting at spacetime curvature beyond current detection? Hawking radiation, once considered only a theoretical curiosity, was revisited as a possible mechanism for producing faint emissions under extreme conditions. Cosmic strings, hypothetical one-dimensional defects left from the early universe, became candidates for explaining minute, periodic distortions. Even vacuum decay, the idea that our universe could reside in a metastable quantum state, with energy fluctuations occasionally leaking into detectable phenomena, entered the discussion. Each avenue carried implications so profound that confirmation would alter the foundations of physics itself. Philosophically, the pulse invited reflection on the possibility of intelligence older than stars, older than galaxies. Could a civilization, surviving eons in a silent void, be responsible for modulation across light years? If the warp-driven or cosmological engine theories held any validity, then intelligence and physical capability in the universe extended far beyond human understanding, operating on timescales and energy budgets that render human history infinitesimal. Even the concept of a message older than galaxies suggested that cosmic awareness may exist on a scale entirely alien to terrestrial notions of civilization, communication, or time. Yet the theories also emphasized uncertainty. Exotic stars might explain some aspects but could not account for the coherence and evolution of the signal. Warp-driven objects were hypothetical, requiring physics unverified and engineering incomprehensible. Cosmological engines suggested intelligence, but evidence remained circumstantial. Multiverse leakage offered an elegant solution but rested on a framework of cosmology still in theoretical infancy. Pre-technological relics seemed plausible but could not fully explain the accelerating modulation observed. Each hypothesis illuminated a corner of possibility while leaving shadows in others. The debates also reframed the signal in temporal terms. Its archival traces, faint yet consistent across decades, suggested longevity beyond known astrophysical lifetimes. The signal was persistent, patient, and evolving. Theories were not just explanations of origin, they were conjectures on endurance. A universe that can preserve such a pulse across time implies structures and mechanisms capable of stability and continuity far exceeding familiar physical systems. Here, speculation met observation, theory met evidence, and philosophy met measurement, creating a landscape both exhilarating and profoundly unsettling. For the scientific community, the signal became a test of imagination and rigor. Each theory was evaluated not just on plausibility but on its consistency with observation, frequency, modulation, evolution, location, faintness, and acceleration. Advanced simulations explored the consequences of exotic stars and warp fields. Quantum field analyses sought fingerprints of brain interactions. Observational campaigns tested for faint emissions in other bands that might betray cosmological engines. Cross-disciplinary collaboration flourished as each domain, astrophysics, cosmology, particle physics, mathematics, contributed tools to decipher an enigma that seemed to defy the normal hierarchy of scientific problem-solving. Through all these investigations, one sentiment emerged: the universe had produced a phenomenon that invited humility. The pulse, whether natural, artificial, or a hybrid of both, was a reminder that human understanding is provisional, always tentative in the face of scales vastly exceeding experience. Each hypothesis carried a lesson about energy, structure, mathematics, time, and intelligence, expanding not just knowledge but the imagination. And yet, for all the speculation, one truth remained: the signal existed. It persisted, it evolved, it challenged. Theories could frame possibilities, but none could yet claim certainty. Whether an exotic star, a warp-driven artifact, a cosmological engine, a multiversal echo, or a pre-galactic relic, the signal represented an intersection of physics, philosophy, and wonder. It reminded humanity that the cosmos is not merely a stage for observation, but a dynamic, enigmatic, and sometimes interactive expanse, capable of revealing surprises on scales both temporal and energetic that the human mind struggles to fully grasp. In the quiet control rooms, as machine learning algorithms parsed the pulse and spectral plots scrolled across screens, the researchers confronted the enormity of what they were witnessing. Each theory, no matter how exotic or speculative, was a bridge into the unknown, a lens through which the pulse could be interpreted, and yet none fully captured its depth. The signal demanded patience, reverence, and the willingness to entertain possibilities far beyond terrestrial experience. Ultimately, the act of theorizing became as important as the act of measurement. To imagine the exotic star, to calculate the effects of warp propulsion, to model a cosmological engine, or to contemplate multiverse leakage was to stretch both the intellect and the soul. It was to confront the profound mystery of a universe capable of sustaining complexity, coherence, and perhaps intelligence across unimaginable distances and timescales. And in this exploration, the signal was not just data, it was an invitation, a question, a challenge, to look deeper, to think broader, and to accept that the cosmos may be older, stranger, and more aware than anything humanity has yet conceived. The signal, delicate and insistent, had become the focus of a global orchestration of observation and experimentation. Across continents, radio telescopes aligned in synchronized arrays, forming an interferometric network capable of resolving details smaller than a single light-year at distances spanning billions of light-years. In deserts, mountaintops, and remote plateaus, dishes of every size turned like ritual instruments, sweeping the emptiness between galaxies with a precision once reserved for pulsars and quasars. Each pulse was recorded, time-stamped, and compared across sites, seeking consistency in a universe where cosmic noise is ceaseless and relentless. From orbit, space telescopes trained on the intergalactic void provided complementary perspectives. Deep field observations, often intended to catalog the earliest galaxies, became windows into the region of the pulse's origin. The Hubble Space Telescope, Chandra X-ray Observatory, and newer instruments like the James Webb Space Telescope contributed layers of data, not just in visible and infrared wavelengths, but across X-ray and ultraviolet bands, searching for faint correlates, incidental energy, or subtle distortions that might hint at the source. Each photon captured was a fragment of a larger story, a narrative written across the spectrum, waiting for human instruments to translate it. On the ground, physicists deployed quantum sensors designed to detect the faintest perturbations of spacetime itself. These devices, sensitive to strains far smaller than a proton's width, tested for microdistortions coinciding with the signal. Was the pulse merely electromagnetic, or was it a shadow cast by a massive structure passing through the cosmic fabric? Meanwhile, neutrino detectors in ice and deep-water laboratories monitored for particle emissions aligned in time with the pulse, searching for evidence of high-energy processes that could accompany the emission. Gravitational wave observatories, such as LIGO and Virgo, added another layer, sensitive to ripples across spacetime that might accompany mass shifts or cosmic-scale motion near the signal's origin. To manage the flood of data, artificial intelligence systems were brought to bear. Algorithms parsed every pulse, analyzing patterns invisible to the human eye, building probabilistic models to predict subsequent modulations, and attempting to uncover an internal logic within the apparent chaos. Machine learning networks sought symmetries, mathematical repetitions, and prime number sequences that might indicate a pattern of intelligence or a natural regularity previously unnoticed. Each new dataset refined the models, but also raised new questions. The pulse evolved slowly, subtly, as if aware of the observation, or constrained by an unknown cosmological mechanism. Meanwhile, proposals for a new generation of space missions began to emerge. Deep space probes, equipped with next-generation antennas and quantum communication arrays, would journey beyond the heliosphere, escaping the background noise of the solar system. These probes would operate in regions where Earth-based interference is negligible, listening to the pulse with unprecedented fidelity. Engineers imagined instruments cooled to near absolute zero, isolated from thermal radiation and cosmic dust, capable of detecting variations smaller than a few femtoseconds, offering the chance to map the signal with a precision unattainable from Earth. On the ground, teams refined their techniques relentlessly. Every conceivable source of interference, from satellites, terrestrial transmitters, atmospheric fluctuations, and even seasonal variations in ionospheric density, was modeled and eliminated. Calibration routines ran continuously, instruments cross-checked, and observations repeated at different times of the day and year to confirm consistency. Predictive modeling became central. By mapping past pulses and their subtle drifts, scientists attempted to forecast the signal's evolution, anticipating not only the next arrival of a pulse but its potential modulation, its internal harmonics, and its faint shifts across frequency. Each prediction, if confirmed, would reveal a new layer of order hidden beneath the cosmic noise. Collaboration extended beyond astronomy. Physicists studying quantum field fluctuations, specialists in dark matter, and theorists modeling space-time curvature all contributed insights. Their collective goal was to create a multidimensional understanding. If the pulse was not simply an emission but a reflection, a modulation of space-time, or a signature of a higher dimensional interaction, then every observable, electromagnetic, gravitational, particle-based, might contain clues. Observatories were networked across disciplines. A neutrino spike could be compared with a gravitational ripple, and both cross-referenced with a microsecond shift in radio frequency. The signal was no longer just a radio anomaly, it had become an interdisciplinary probe into the universe itself. As the data accumulated, patterns slowly emerged. Slight correlations between harmonic layers hinted at interactions between different scales of physics, potentially bridging classical astrophysics and quantum mechanics. Variations in amplitude suggested either a moving source or environmental interference of unknown origin. The pulse's acceleration remained, a stubborn, almost conscious drift that no model fully explained, challenging researchers to reconcile relativity, quantum theory, and cosmic-scale energetics into a coherent narrative. The work demanded patience. Months, years, even decades of observation were required to confirm subtle trends. Observatories operated in shifts, around the clock, continuously logging, analyzing, and sharing data in global networks. Each alert, each detection, was a moment of anticipation, an ephemeral alignment between human instruments and a cosmic rhythm. For the scientists involved, the endeavor was not simply technical, it was existential. The universe had whispered across billions of light years, and humanity was straining to listen. Speculative mission concepts extended even further. Some suggested deploying constellations of microsatellites, each equipped with interferometric receivers, spread across the solar system to triangulate the signal with unmatched precision. Others proposed quantum-entangled sensors that could, in principle, detect correlated events across vast distances instantaneously, offering a bridge to phenomena beyond classical causality. While such technologies remain largely theoretical, their consideration reflected the seriousness with which the pulse was treated. It was not a curiosity, but a potential probe into the deepest structures of reality. The global scientific effort transformed the pulse from an isolated anomaly into a multidimensional object of study. Its faint, accelerating rhythm became a laboratory for testing the limits of human ingenuity and technology. With each telescope aligned, each quantum sensor primed, and each algorithm trained, the universe offered more of itself to comprehension, yet withheld full understanding. The signal's persistence reminded humanity that discovery is iterative, that knowledge emerges slowly, and that the cosmos often communicates in a language far more subtle and patient than human expectation. In the quiet of the control rooms, observers reflected on the scale of what they were witnessing. Instruments hummed in synchrony, digital plots scrolled endlessly, and AI models generated predictions with every new pulse. The collective gaze of a global network of human curiosity fixed on a faint rhythm drifting through the emptiness between galaxies. Each measurement, each calibration, was a testament to endurance, a meditation on patience, and an acknowledgement of the universe's vastness. Through this convergence of tools and techniques, humanity edged closer to decoding the pulse. Each method, radio arrays, space telescopes, quantum sensors, neutrino observatories, gravitational wave detectors, AI systems, revealed only fragments, yet collectively, they formed a mosaic of understanding. The pulse demanded both rigor and imagination, precision and patience, observation and reflection. It was a signal, yes, but also a question, a persistent, accelerating, faint pulse challenging humanity to listen deeper, measure longer, and think beyond the confines of known physics. As the networks of observation and experimentation expanded, the pulse remained patient and persistent. It continued its subtle modulation, drifting through space-time with a rhythm that human instruments now mapped with unprecedented fidelity. Yet each answer produced new questions. Each correlation hinted at deeper structures. And each detection was a reminder that the universe communicates not only in light or energy, but in patterns, in persistence, in the slow, inexorable unfolding of mysteries that span both time and space. In this relentless pursuit, the pulse became more than a signal. It became a teacher. Through interferometric arrays, quantum sensors, space telescopes, AI decoding, and interdisciplinary collaboration, humanity learned to wait, to calculate, to hypothesize, and to reflect. The universe, in its quiet majesty, continued to speak across the void, and the act of listening, precise, patient, and reverent, became itself a bridge to understanding, offering the possibility that one day, the rhythm, the modulation, the accelerating cadence, might finally be understood. Humanity has always listened. Long before our instruments could pierce the veil of intergalactic darkness, our ancestors tilted their faces toward the sky, noting the silent rhythms of the stars, the waxing and waning of moons, the slow dance of planets across the night. Telescopes, primitive at first, glass lenses bending starlight into comprehension, became the first language through which we approached the cosmos. Later, radio waves, whispers of energy invisible to the eye, allowed the universe to speak in frequencies we had only begun to perceive. In every era, the act of listening has been an expression of hope. Hope that somewhere beyond the familiar, beyond our fragile planet, there might exist resonance, presence, or knowledge. And now, in the vast void between galaxies, a new voice has emerged, subtle, deliberate, and persistent. A signal threading its way across billions of light years, connecting the silent stretches of space with human awareness. This signal challenges the very foundation of expectation. Its structure suggests intelligence, or at least coherence, yet it might arise from forces older than stars, from processes that predate the formation of the Milky Way. It hints at life, yet life in a form entirely alien, perhaps extinct, perhaps transdimensional, or perhaps encoded in the mathematics of the universe itself. Could it be a civilization that lived when the cosmos was young, whose echoes now drift across voids we scarcely comprehend? Or is it a natural phenomenon, a relic of primordial physics, a pattern emerging from the universe's own laws, a voice that has existed since time first began to stretch outward? Each possibility expands the imagination, compelling a quiet reverence for a universe that is not only vast but aware in ways our current language cannot capture. Einstein dreamed of a comprehensible universe, a cosmos governed by symmetry, by equations as elegant as the patterns of the night sky. He imagined that through reason, through patient observation, humans might grasp the order underpinning all things. Hawking extended this vision, pursuing unification of forces, seeking the elusive connection between quantum fluctuations and the vast curvature of space-time. In the context of this signal, their dreams gain new resonance. The pulse may represent a fragment of that deeper order, a hint of laws beyond current comprehension, or a whisper of intelligence capable of harnessing energies that dwarf our understanding. It is a reminder that the cosmos is not merely a backdrop for human inquiry but a participant, a presence whose complexity humbles even our most brilliant minds. The emotional weight of this discovery lies not just in the signal itself but in the act of recognition. To observe a pulse that may carry a message across time and space is to confront mortality and longevity simultaneously. The Earth, young and ephemeral, spins in the shadow of cosmic epochs, while this signal has drifted patiently, imperceptible to all but the instruments we have trained to listen. It asks a question that transcends generations. Is there coherence in the universe, or intelligence, or purpose? And in answering, even partially, even imperfectly, humanity acknowledges both its vulnerability and its audacity, its temporal finitude and its capacity to reach beyond itself. The rhythm of the pulse, accelerating yet persistent, suggests intent or, at the very least, a form of order that our current understanding struggles to explain. Its faintness speaks of endurance across unimaginable distances, a patience beyond human measure. And yet, for all its alienness, it invites empathy, the recognition that across the vast, cold void, something has persisted, something has maintained pattern and structure, waiting for recognition. In that sense, the signal becomes more than data. It becomes a narrative, a bridge between human curiosity and cosmic phenomena, a thread connecting the ephemeral with the eternal. Contemplation of this signal also confronts us with the philosophical implications of scale. Human history, fleeting and localized, is dwarfed by the timescales implied by the pulse. Galaxies rotate and collide, stars are born and die, and yet this signal drifts through voids untouched, perhaps unaltered, perhaps evolving in ways only faintly detectable. It situates humanity in a universe that is ancient, restless, and full of echoes, a cosmos whose rhythms are not dictated by our lifespans but by processes that span billions of years. In listening, we participate in a dialogue far larger than ourselves, tracing patterns that exceed both imagination and the limits of current measurement. There is also the possibility, profound and unsettling, that the signal may carry intelligence beyond comprehension, a civilization whose motives, methods, or consciousness are entirely foreign. Its acceleration, its modulation, its subtle evolution over time hint at agency, though of a form that cannot yet be quantified. Even if it is not intelligent, the mere existence of such coherence across the intergalactic void demonstrates that the universe is capable of organizing complexity in ways that challenge our assumptions about randomness, causality, and cosmic isolation. Each discovery, each new layer of analysis, illuminates the depth of the unknown, reminding humanity that curiosity and humility must coexist in the face of such profound mystery. In considering what this signal represents, the mind returns to the act of listening itself. Every pulse received is the culmination of decades of human ingenuity. Telescopes constructed, algorithms trained, international collaborations formed, instruments tuned to extremes of sensitivity. Yet despite this sophistication, the universe continues to withhold full meaning. The signal is simultaneously accessible and inscrutable, inviting observation but defying final comprehension. In this tension lies the poetic heart of scientific exploration, the balance between knowledge and wonder, between discovery and awe, between the known and the infinite. The pulse is also a mirror of our own temporality. It reminds us that civilization is young, fleeting, yet capable of reaching across cosmic distances with instruments born of curiosity and imagination. Each detection is a testament to patience, to the slow accumulation of knowledge, and to the perseverance required to understand phenomena whose scales dwarf daily experience. The signal asks not only what we know but what we are capable of understanding, challenging humanity to expand not just its technology, but its perspective, its philosophy, and its capacity for wonder. Ultimately, the cosmos is not silent. Its vastness, its voids, its dark expanses are not emptiness but a medium through which subtle messages, ancient processes, and perhaps intelligence itself may whisper. The signal that has emerged from the depths of intergalactic space is a reminder that the universe is ancient, restless, and intricate, filled with layers of activity and interaction that may never be fully decoded. And yet, the act of listening, patient, reverent, persistent, allows humanity to participate in that cosmic rhythm, to witness, to measure, and to imagine connections across unimaginable spans of space and time. In the quiet aftermath of each observation, in the moments when plots scroll across screens and algorithms hum in calculation, there is a profound stillness. The pulse continues its journey, indifferent to recognition yet capable of eliciting wonder. It rises from the darkness like a faint cry, a rhythm that threads through the emptiness, persistent across the eons. Whether it is the signature of physics beyond comprehension, of a civilization long vanished, or of structures older than galaxies, the pulse embodies the universe's restlessness, a gentle insistence that existence is neither quiet nor static, but a dynamic interplay of matter, energy, and perhaps consciousness. And so, the signal continues to arrive, crossing the void, reaching Earth after billions of years, a voice calling from the depths of time and space. Its meaning remains unresolved, but in its arrival, humanity glimpses the vast possibilities of the cosmos, the hidden order, the potential for intelligence, the extraordinary endurance of processes that stretch beyond human comprehension. It is both a question and a revelation, a whisper and a lesson, reminding us that to observe is to participate, that to listen is to understand, and that the universe, in its profound immensity, has been speaking long before we arrived, and will continue long after. Somewhere in that dark ocean of galaxies, filaments, and voids, the pulse persists, an echo threading through the ancient structure of space, rising patiently, deliberately, toward the conscious curiosity of humanity. And in that rising, in that faint modulation crossing billions of light years, lies the ultimate invitation. To continue listening, to continue measuring, to continue dreaming, and perhaps, one day, to answer a question we have only begun to understand.